Hello, everyone. Welcome to today's webinar. My name is Khalil Doheny. I'm the head of content here at Digital Niche Agency. Today, I have Charles, CEO and founder of AtomBeam. Charles, how are you doing today?
Good, Khalil. How are you?
Doing good. Hope you had a fantastic New Year. Hope everyone in the tuning in today had a great New Year. Where's everyone tuning in from? We just getting started here. Kind of give it a sec for people to trickle in, but curious where people are tuning in. Charles, where are you coming in from?
Yeah, I'm actually outside Boston near Hanscom Air Force Base. And I'll go into the reason why when we're talking. But it's a pretty good thing if you're an investor in AtomBeam.
Awesome. I'm currently tuning in from LA. We've been, getting hit with rain here for the last couple of weeks now. It's, I'm a little over it, but I'm sure in the East Coast, you guys, this is a normal thing for you guys. So I do apologize.
Yeah. Yeah. Oh, it's raining. Oh, shut everything down.
I know. Lots of
California,
There's one time I was moderating a webinar and I told him, oh, it was a little cold here in LA. And the guy was tuning in from New York and was just kind of got offended that I said it was cold here in LA.
Right. Yeah.
Yeah.
Yeah. That was like 49 degrees. I mean,
Exactly.
it hasn't happened often, but boy, I gotta tell you, we had to get out the heavy equipment.
Awesome. I'm really excited for the webinar today. We're gonna, see what AtomBeam has been up to, talk a little bit about 2022 and really see what's going on in 2023. I know Charles has a lot of great updates for you all. If you want to learn more about AtomBeam and aren't an investor yet, really recommend you guys to go check out the Start Engine page. There's a lot of valuable information there. We just hit an amazing milestone. Fortunately, due to the guidelines, I can't mention that specific milestone on the call, but check out the page. You'll see that milestone. It's truly amazing what they're doing out there and with AtomBeam. I'll add the link here in this chat. There you go. That's for everyone to take a look at. With that being said, Charles, the floor is yours.
Great. All right. Thanks, Khalil. Appreciate that. So welcome everybody. And, I appreciate everybody tuning in. It's a pretty cool thing that we're still here, that we're still going, and things seem to be really coming along. I think personally that 2023 is going to be a big year for us. I think it's a year that all these things that we've been working like crazy on, not all, but enough things, significant things, that I think this next year is going to really start bearing fruit. We have a product that takes more than just a few clicks to use it. And that makes it harder to get people to start using it. But once they do, it gets built into things. And those things are many things, thousands, millions, billions even. And so what I'm going to do here is talk a little about sort of like our status, what we're doing now, but also about how the AtomBeam thing really scales. What happens when we really catch fire? And so I will walk you through. I put together a little presentation, and I can walk you through that. And I'm sure we'll have questions. But at any rate, so if you like, I'll just get going and share screen and start that up.
Yep. And if you do have a question throughout the presentation, please leave them in the Q&A box below. As Charles mentioned, we'll have some time towards the end to get those questions answered.
Right. Yep. And it's a pretty short presentation. So I think we will get a lot of chance for everybody to ask questions. And don't hesitate to put in questions. And Khalil, don't hesitate to interrupt me. I am happy to address them right on the spot. So just quickly, here's what the agenda is. It's really to talk about where we are right now, talk about some of our customers and the ones that we have targeted, as well as partners, and then talk more extended way about things as we see it that could happen here that could really make us into a pretty big noise. That, by the way, is a Saab Gripen, which is our customer, Saab's aircraft, into which they are in the process of integrating compaction. So pretty cool looking, and something I thought would look nice. So quickly on what we're going on, and as to mention a little more on the start engine raise, we were thinking about closing it out this month, but we've decided to extend it at least for a little while longer. Not giving you specifics on how long, but it won't be forever. Another thing is, just in terms of an update, we reduced our fixed costs last quarter with the goal of saying, okay, we could be going into a recession. Capital will be harder to get and so forth. And, just in general, being prudent, trying to keep ourselves in a position in which we are in good shape. We don't have to worry about running out of money, and that's the thing that kills more startups than anything. So we did a lot on that end of things. And then in terms of what our goal is for this year. So goals. One is that we want to get at least 2 phase 2 contracts from the Defense Department. We are hopeful that we get one this month, which leaves only one to get. So another thing is 10 customers and 10 partners. So we've got a few customers, we got a few partners, so we just want to start ramping that. We have 18 patents now. We think that we can get to 25 by the end of the year. That is a formidable barrier and makes us look pretty good to prospective customers, end users, big companies, partners, and so forth. And finally, we want to hit at least 100K monthly recurring revenue by the end of the year. I think it's pretty doable based on all the activity we have. In terms of how we are organizing operations, we have retained core engineering expertise, but we really want to keep our fixed costs low, which means that for the time being, we're trying to outsource to engineers who know our code, and as opposed to having them in-house, and it reduces our risk. We want to focus a lot on getting partners. We think that is how we get over the hump here, and be able to really leverage this thing. And finally, we think that moving into appliances so that somebody like a big company can take a dongle and plug it into their whatever it is, and or put it on a gateway, which is how devices connect to internet or other ways of communication. And if its compaction is built in already, all they'd have to do is switch on their device and the compaction is up and running. That is a very good way of scaling us up. And I'm going to go into a lot more detail on that. That's a key part of this thing I'm going to talk about today. So really talking very specific about some of these partners and customers. We have partnered with, as I think everyone has seen before in some place or another, with Cribble. They have very interesting, they're very high profile. They have a very interesting way of dealing with piles of IoT type data to make it more functional and usable. Crosser I've talked about, that's a software IoT platform. I think everybody has seen that we've partnered with Lockheed Martin, and they're highly supportive be a source of capital too, as well as Inmarsat. Just met with Inmarsat last week at length. They're super high on us and very supportive. Saab, as everybody knows, is a customer. So is CrowdPoint. We're working on a very interesting product that I can't talk about too much, that could be a big deal. And you heard from them in our last call, our last webinar, but we're getting down to brass tacks now to really talk really seriously about it. Inside Terra, they are a remote mining monitoring firm that sends their data over Inmarsat. Biggest point there is they confirmed to Inmarsat, they're an affiliate of Inmarsat, and they confirmed to Inmarsat that our stuff actually does work, and they did all the technical work. And you can see down there all the partners and customer targets we have, and we're in some stage for virtually all of them in discussions. So I can't say every single one. There's a couple here that are speculative, but almost all. So let's talk about the go-to-market here. And for us, that's the critical piece. The easier we make it for somebody to test it and try it and integrate it and use it, the better. And just as important is the perception that it is easy to use and easy to integrate. I think in almost universally, it's a lot easier to actually do it than it is than the perception is that it works easily, it integrates easily. So changing that perception is part of what we're trying to do, but also making it even easier is also a key thing. So how do we do that? Well, first thing is we have this customer portal that anybody can go to. You don't need any engineering skill at all. It's completely no code. You upload a data sample, and it'll come back and say, here you go. Here's your code book. Here's how much will reduce your data. It's really easy. And that has been a really good thing. We've been able to showcase that to a lot of folks. Then the next thing is the platform integrations. So that really means that, all right, if I use Crosser and I want to flip a switch and turn on AtomBeam, it's there already. I don't need to futz with anything. I don't need to do any integration myself. If I'm using Crosser, I have access to AtomBeam by simply paying a little more money. And that, again, as is the case in every single instance, the most important thing for us in terms of priorities is making this easy and simple to use. And not even that, and it's, again, not just making it easy, making it perceived to be easy. And then the last thing we're going to talk about here is putting compaction into an actual piece of hardware, like a gateway or a dongle, or actually in a chip that sits on your logic board. And I'm going to talk some about that. So, and Khalil, anything you want to mention now?
Let me see here. We do have a question already. Is do we see ability to use this type of compaction for the telecom industry?
Yeah, totally. I mean, think about it this way: if you can say you're AT&T. AT&T is actually somewhere, I can't talk about that, but let's say you're AT&T, and let's say you want, and you're a player in the IoT data transmission market, and your data, your network will send data 4 times faster, and it adds security when it does it. And by the way, your network has 4 times more capacity. Do you like that idea? I mean, seems like a good thing, right? So the answer to that is yes, absolutely. It doesn't qualify as the lowest hanging fruit, though, and the reason why is because we really want to talk to guys who have an acute problem they have to solve right now. And the most of the IoT networks that the big carriers have are not at full capacity. And, you know, in some cases, well under full capacity utilization, which means that they don't have an acute problem, which means that that isn't on the top of the list. The top of the list are guys who, you know, like if you look at the SOP situation, their choice is upgrade the radios and at the cost of millions and millions and millions in their fighter aircraft, or adopt compaction. And they have to do something now. Makes it pretty simple. Yep, okay. Compaction becomes a key right now kind of thing. Same is true with, you look at the Inside Terra situation. They would have a hard time selling their service if they had to pay full price for data going over Inmarsat satellites. They can charge a lot less. That expands their market dramatically. And therefore, it's of big time value. There's other situations that fall into one category or another, but longer term, somebody in like the big cellular carriers are absolutely on the radar. It's only a question of priorities and who's in acute need today. All right.
Awesome. That's
All
the
right.
only question I see so far. So if you do
Okay.
have any other questions, please just add them into the chat box and we'll make sure we're asking them.
All right, great. So this is a little thing I put together that sort of like talks about how, you know, this whole thing with perception of the difficulty of integration works with us. So as you can see on the left scale, you have a perception of it's hard to do versus a perception of it's no brainer, it's already there, whatever. And at the bottom are small volume and gigantic volume. And so the key things are, you know, when we talk about down at the 1 is the engineering intensive companies that have no issue like Saab, lots of engineers integrating some technology like ours is not going to be perceived as anything negative or a problem or anything like that. And they're actually pretty keen on it. And so on that basis, yeah, I mean, they are adopting it, and it is a big deal, and it is something that is acute, and therefore, boom, you know, we're in there. And then the next step up is something like pre-integration with things like, and there's this thing called FPGAs, field programmable gated array, which is just an approach that basically can put us into a little chip, and you can put it in a dongle or whatever, or in a gate, and you can plug it into things easily. So if you're somebody who wants this, but doesn't want to undertake really much of any integration, that's a pretty simple, easy way of doing it. Let's say you had, a lot of whatever Caterpillar tractors, and you wanted to use it in those tractors, and you could plug it into like a USB port, and you're up and running. But the real deal, how you get to mega scale, is something called an Asic. and I'm going to talk about what that is. But that would be really either an ASIC or a way of updating your software so that there's no question that all you're doing is an update that kind of looks like updating your operating system in your computer. So this is a key thing, is to understand this piece, because being there already is the critical point. Khalil, do you have anything you want to mention?
Yeah, how many patents are in the fully functional stage versus the infancy stage?
How many patents?
Mhm.
It's hard to answer because some of the patents are based on concepts. Well, some of the patents are just sort of like, this is the baseline, here's how it works. And then some of the patents are, this is a new feature that we will build or we have built. And then there are some patents, and I can't tell you exactly how many, but that are either we have prototyped it, we've built it in, it's already part of what it does, but we mentioned this aspect of it in the patent that is like let's say security. All right, so you make our stall, you build compaction, and you put compaction, you get compaction in use. But once it is in use, you are automatically getting security. And so you want to patent that irrespective of the fact that it's already there. So you want to say it's also adding security. And then you toss in other stuff with that, we could do with security. So when you look at a security patent, for example, you might see, here's what it does baseline, but it also will do, we could do this and we could do that. And maybe we built those things, or maybe we haven't yet.
We have another question here. Is your product seems intuitively like every company in your target market should find / realize value from. So why aren't more customers coming up to you? Not asking why sales cycle takes time. That's a separate question. Why aren't all satellite communication companies signing up for RFQ or RFX/Y/Z?
Yeah, no, it's a good question. And it's a question we pound on all the time, because I think that it really comes down to this. You got to look at the individual satellite company. Do they focus on IoT? If they have a significant focus on IoT, do they have the bandwidth right now to accommodate the amount of demand they have for that bandwidth? And is there a perception on their part that, okay, maybe they can handle it, the amount of demand they have right now, but will they be able to handle the demand that will imminently be needed to address the opportunities that they perceive? So, case in point, there's a company that traditionally hasn't done autonomous machines, but now are planning to. And that company is going to increase the amount of data flow dramatically. And so if you're a company that says, no problem, I have plenty of bandwidth, you're not as concerned as a company that says, we're kind of on the edge here, we don't have enough bandwidth, and so we have to work with AtomBeam. And so I would say that part of it is lack of awareness, and that's probably number one. And we're working on that. But part of it is how concerned are they about the bandwidth that they have? And are they really focused on IoT as a big opportunity, or is it just sort of like either they don't do it at all, they just do broadcast or something, or are they kind of dipping their toe in the water with IoT, or is it like a major thrust? But I'd say out of all those things, I mean, we only have so many people and only so much we can do. And we think that part of how you get there is really focusing on one partner, which is for us Inmarsat, and on DoD, which is a great way of showing the world, yeah, this works, and DoD has blessed it, and all that. And you put those things together, and I think, and the other thing is too, is that I should have mentioned this before, satellite operators versus satellite building guys. Like if you were to look at like a Lockheed Martin, they do both, but they're not building satellites for the commercial market. They're building them for, by and large, I don't think, at any rate, they're mostly DoD, right? Those guys are providing an integrated solution to DoD that we are a really key part of. And I think, I mean, they're like honest, like crazy, right? And part of it is their perception that they can deliver something that has a lot more value than their competitors if they have our stuff. So I would say, again, most of it is just awareness, but it also comes down to how much emphasis they have on IoT and whether or not they have an acute need. Okay.
And, yeah, you can continue with the presentation.
All right. And okay, so speaking of DoD, let's talk a little about that. We particularly have a lot going on with the Air Force and the Space Force. And in part, that's because we have, really good relationships. And that the Air Force has an organization called AFWorks, which is their kind of centralized point that they use for funding smaller companies. And that makes them a lot more organized around those processes, and they're more open to thinking about, okay, we haven't decided that we need this, but tell us what you've got. And that makes a lot of difference in terms of us, because people don't even think that they can do anything like what we can do. And so nobody posts an RFP about it, And General Tata, you've met him. He's got relationships that are key there. And we also have retained a company called The Outpost that includes people who were in AFWorks and SpaceWorks. So relationships are big, just like everything else on the planet Earth, right? And so we have a contract right now, a small one right now, the $75K, which is how you get to a phase 2, which is $1.2 million most easily. We also were selected, but we weren't funded for a phase 2 last year. So we submitted a new application that was new and improved with a very strong letter from Lockheed that said that they would basically do all the work and let us get paid for it. So at any rate, we'll see. We're going to hear soon, later this month, about that. And then we have a couple other things that we're working on that would be additional proposals. And then tomorrow, I'm actually sitting in a hotel room near Boston, and I'm going to be meeting with a major general who's in charge of procurement for command, control, communications, intelligence, and networks for the Air Force. And so he's like the most important general for us. And fortunately, he suggested setting up a meeting, which we did, and tomorrow is the day. So anything you want to stop me for? He said, getting a drink.
Realized I was on mute there. Yeah, we do have a couple questions coming in.
Sure.
This question says, thanks for the previous answer. Can you clarify, is this only for IoT? Can you not also apply compaction to all other types of data feed coming in from space?
It's a very good question. So the answer is no, it won't work on everything. We are dependent on finding patterns in data. And so the world is divided into things with, data that has patterns and data that patterns have been squeezed out. And so for video or most images, and video and images mostly throw out, I mean, they use lossy compression, which is a lot different than lossless, which is what we are like. Lossy compression basically says, okay, we're going to eliminate 90% of the original data, and then we'll compress what's left. When you start with eliminating 90%, you're getting it down pretty significantly already, and then you're getting rid of half of what's left or so, which gets things down so that usually you're going to get 95% reduction. But that doesn't work for you if you need the data to look like it is when it left you. It's fine if you're a human being looking at video and you can't tell the difference between whether this bit of data was there or not. Whereas if you're us, you've got to have those patterns. And if you've used lossy compression on it, you won't find patterns. And even pre-compression, it's less likely to have as many patterns. So generally speaking, for anything other than video and pictures, we're going to be dramatically superior. And there's no question that, for anything that isn't video or pictures, we're better. And then for those things, push them off to the side. One day, maybe we can address that. We've got some ideas, but no guarantees at all. However, there's another thing that's really interesting, which is we are now part of this phase one that we have going with the Air Force right now is about LiDAR data and radar data. And as some of you probably know, there is competition now, and mainly it's in the auto industry, between the people who say LiDAR is the way to go, which is really beaming light beams out and getting perceiving objects and so forth by using light, laser beams to get the bounce back. And so you build pictures around that. The problem is with LiDAR and with radar, the amount of data is gigantic, which is okay for some things. But if you're sending the data from whatever it is to something else, like from a drone or from an aircraft or from a ship or a guy or whatever, and you want to send it somewhere else, is too much. And so the Air Force and Space Force are really keen on figuring out, like, can we do something to get that smaller? And it even isn't just them. We also have a big automotive chip company that wants to look at using us too. And so we're showing in early stages about 80% reduction. We think we can do better because there's an awful lot there that's still repetitive. So, when you say, does it work on everything coming from space? No, but a lot of things are moving to radar and LiDAR that are right now video. And it's a big question about Tesla, for example, is they are video and most of the other guys want to use LiDAR. So we'll see who wins, but in any case, it's still a gigantic market, whatever, Anyway, so with that, should move on.
There's another question here.
Okay.
What is your specific go-to market strategy for mass market adoption? And do you work with a marketer to get your message out?
Yeah, good question. So part of what we're going to be talking about here in this presentation is the go-to-market. It's a big it's the biggest, toughest nut for us to crack. And so, but I'll walk through that and talk about that in more detail. What was the other part of the question? I'm sorry.
Do you work with a marketer to get your message out?
Oh, yeah. Well, we kind of do and kind of don't. We for advertising, we use Khalil's company, right? And so that gets the word out to an extent. We also work with this company called the Outpost that I mentioned earlier. They're specific to DoD, but they also, know a lot of people that are DoD contractors, the big guys, the big ones. But for what we do, because it's not really a mass market thing, it's really the best things we can do are get the one-on-one connections with individuals who are in decision-making positions at big companies. And so, like, I was at CES last week, and you kind of bypass this guy and that guy, and you drill down and find the right guy in a given, thing. Like there's a really I'd say I met like at least, I don't know, 15 different, companies, but 2 or 3 really stand out. One was, I'll mention this because it's an interesting thing, and I think I don't have anything here about it, but it's called an MVNO. And what they do is they will do a value add purchase of bandwidth from like a cell carrier. So they might go to AT&T and say, okay, I'm going to buy 10 terabytes of the data, your data. And and then they add some value to it. They have it make a little gadget or something. It says, okay, for medical purposes, we have this special thing. So you can we'll take your data, or we will do the monitoring that creates the data, and then we'll send it to wherever, to some place where you can actually go use it for something. And so, but the core thing for those guys, for MVNOs, is what do they spend the money on? They spend the money, a lot of it, on buying the 10 gigabytes or 10 terabytes of data or whatever it is from AT&T, and then reselling that 10 terabytes to a bunch of different users. If they integrate our stuff, then they can sell 10 terabytes worth of data, but they only need to buy 2.5. And if you're them and one of your biggest costs is sending all this data, I mean, this guy I was talking to he's going like, whoa, what? Yeah. He was like, he went nuts. It was a great conference. I love those. But at any rate, how do you expand your margin? Boom, like overnight. And these guys make the chips and make the little boxes and stuff that get sold. So they sell somebody a box and they buy a lot less bandwidth, and boom, their margin go way up. It's a huge deal for them. So there's several of those guys out there. There's a bunch of them, actually, a lot of them. But it's a big thing, and it's a market that's great for us, but just a question of like how much time we can spend running around after this and that. We've got to keep focus. We're really focused on satellite and DoD, and a few really limited things like aviation related things and so forth. But at any rate, so long as we don't have to strain our engineering, then there's a lot that can be fair game for us that doesn't change what we have to do internally. So sorry for that deviation, but it's sort of interesting.
We do have another question. If you want to continue with the presentation, and we can save some of the questions towards the end. I know.
All right, let's save one and I'll keep going here. Because it could be I answer something as we go. Okay, so I want to talk about some of the big things that, because like I think everybody has a pretty clear idea that this is really important and big and could turn into billions of things and everything. How does it actually get there is the question. How do you get from this is a great concept to it's actually in use in a lot of things? And so I'm going to talk about that. And I talk about some of the applications that are critical to, or I shouldn't necessarily, it's like some of the key things that users perceive and need and how they would actually get it in their hands. So first thing I'm going to talk about is something called an ASIC. Now an ASIC that's a chip that basically is like a little computer. It's got all this stuff in it. It's got a microprocessor, it's got RAM, it's got the whole deal. And but it's very specific to doing one thing. And in our case, it would be doing something, it would just be doing the compaction. And it's, you can make fancy ones and less fancy ones and all that. But basically, if you use an ASIC, you're eliminating all the other things that a CPU has to worry about. It just does this one thing, and everything in it is oriented to doing that one thing. And so what you would do is we would build this ASIC, and or a partner would. And then if you're building a cell phone, or you're building an airplane, or you're building a whatever, you would spec into the logic board, the ASIC. And so compaction could be just a standard thing that gets stuck on basically any board that you want to communicate securely or really way faster, or both. And it's very simple, very easy to use, and nobody even knows it's there. It's just another chip on the board. And that is how you get to be gigantic, because Apple would stick it on in phones, and so would Samsung, and so would, everybody and his brother. And we would just get, a little payment every time somebody bought one. So somebody'd order 1 million chips and we get paid whatever, whatever it turns out to be, because the amount they pay over time would get to be not very much per chip, but times 1 billion, even like a very small number, adds up. So that's the real game here, is to get it onto ASICs. And once it is, it's game over. It'd be like, this is a big deal. Feel free to interrupt me, Khalil, if you have a thing you think is relevant or whatever.
Yeah, we can keep going.
Okay. So another thing is the searchability. Why is this doubling up? That's odd. Hang on. I don't know why. Oh, anyway, okay. So searchability. So one of the biggest things that is an issue with compression is the fact that when you have data at rest, it's called data that's stored in these giant data centers, you can't do anything with it until you decompress it. You can't read it, you can't search it, you can't randomly access pieces of it. It's all sitting there. And so you say, okay, I know somewhere in this big block of data is this thing I'm looking for, or I need to look at, say you're talking genomics, and I want to look at 1 million or 2 million genomes, and out of the whatever number of billion pairs, base pairs there are, I want to look at 12 base pairs in those 1 million genomes. So you might take days decompressing all that data just to look at 12 genomes out of 6 billion or whatever it is. I can't remember how many it is for humans, but to look at 12 base pairs on that giant genome, I need to decompress it times a million. And that takes forever. Lots of computers, lots of computing power, lots of time. It's a big pain. And that kind of thing means that if you're doing compression research, there's a good chance that what you're doing is trying to figure out how to read it while it's compressed. And we can do that now. This changes the world. And when you talk to, and I know it's really hard to get your head around what a big deal this is if you're not a data scientist, right? But it was for me, at least. And if you are, though, then this is like a bigger deal to them, a lot of them, than it is like even the reduction and the extra security. They go, this can change everything. Don't you see? You know, like this is how, like Snowflake and Splunk and all these big genome companies and everything changes. I mean, we've had what was it, Pfizer and Roche both came to us and said, hey, we'd like for you to look at you doing this stuff and everything. And we was like, well, we know, but we got to stay focused, etc. At the same time, I mean, you put a few bucks in this, especially if you could just hand this out, put it in an Asic, they put it into the servers that are used. Boom, and you would need to build some APIs around the standard search stuff, but that's very much easy for engineers, very standard kind of stuff. And then, you got a game changer here. This is like, so it's like all these companies have these giant data lakes of data, mega amounts of data, that like, you think about like, okay, we always talk about how much IoT data gets generated all the time, right? It's like tons and tons of it. Where does it go? Okay, I'm monitoring, all right, my engine's going to blow up, so I got to do something about it or whatever. But all that data ends up somewhere, and somebody wants to go in and say, okay, I want to look and see like all the times the engines blew up, what happened before, and therefore this. So they got to go through all this stuff just to get the data back out and figure it out. They don't even know where to look a lot of times. So this can solve all that stuff. It's an enormously impactful thing. Do you want to interrupt me?
Feel free. Trying to find the mute. Yeah, we have two questions here. The first one is, have you approached the Earth imaging companies like Planet, Maxar, or I don't want to mispronounce this, Blacksky? I would imagine those would be prime customers for data compaction and in turn their customers.
If it's images, no, for the reasons I talked about, because so again, image compression, they don't keep it, most of it. They get rid of almost all the data. Why? Because I can't tell, or nobody can tell what colors that this has a color that isn't on the spectrum that humans can see, or that this pixel, the next pixel over is only slightly different, and therefore I'm going to just say the same pixel again, or whatever. And so, we would not be useful to, I mean, just put out of your mind, like the whole thing with video and with images. Now, that's not to say, like, if we were to look at like one of the things out there is what about web surfing and stuff, which includes images. So we've looked at that, and overall, we save about I mean, it looked like 60% or so, but call it 50 or whatever. So, and why isn't it more like 75 like most of ours? And the reason is because there's images and stuff thrown into the web. And so we don't process those. We just say, we're not touching that. And that means, in effect, that we're reducing the size of all the stuff that isn't, and therefore maybe doubling the speed of just a typical web surfing, texting, email thing. But in essence, with all the images stuff, really we're not going to get there because, again, we need to have patterns, and patterns are eliminated when you have images and video.
Then another question here is, based on your searchability function, it sounds like generative AI would be a massive market that would benefit from compaction as well. Could be huge.
Yep. I mean, I'm not going to disagree. I mean, but I got to tell you, if you're us and, you've got to pick your spots, because if I had an army, give me an army, and that changes the picture. But if I don't have an army, I got to say, okay, where do we go? I mean, really, it's like, again, where the big perceived, I've got to have some solution now or I'm really screwed kind of thing. And where have we proven that, yeah, this is effective? So if you look at Saab, downlink, boom, anything in aviation, downlink, we're golden, right? Proven it, they're right, referenceable, etc. DoD, they pay for you to do research. Okay, that works for me. And they will also be a big validation for not only aerospace, but aerospace, both aircraft and satellites. Inmarsat, same deal, proven it for satellite stuff. We can show it. They endorse us and all that stuff. And they wouldn't want to endorse us to their competitors, but still, that's proven real, and we can focus on it and go bang away on other guys in the same area. That's why.
And most companies have data analytics departments. Can they use data compaction?
Yeah, sure. I mean, is the response. Yeah, because if they store it using our stuff, they can do the research like that. I mean, think about the difference between like a guy looking at those million genomes who's like some high-end PhD who spends days decompressing and da. Instead, he can type in the search terms and he gets it in a second, what would take him days. I mean, really, it's an incredible thing, what we can do. I just wish we had the resources to exploit that right now, but it is what it is.
Yeah. The question here is, how soon will you have compaction ASICs ready to take to market?
Yeah, that I think so. Doing an ASIC is a big, heavy project. It's like you got to do the FPGA first, and then you have kind of designed the software part of the ASIC. And to do it on our own, that would take a long time. It would literally be a couple of years to really get there, and tens of millions, like at least $10 million, probably more. So what do we do instead? Well, we are going to, we're working on one of the DoD proposals I have is to do an FPGA. And we go to the DoD and we say, look, we can do an FPGA. You could put it on your devices and your aircraft and blah, 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 really quickly and easily if we've done this FPGA. And so we partnered with a hardware firm that does FPGAs, and we're going to propose it to the Air Force. Get to an FPGA makes it a lot quicker to get to the ASIC. The other thing we want to do is partner with one of the big chip companies that makes ASICs. What do? They build the ASIC out. For them, it's like pocket change, right? They build the ASIC, they pay us something when they sell one, and they sell them, and they're like, have all the reason in the world to sell them, right? And so they sell gajillions of them, and we get a payment every time. So as opposed to raising all the money ourselves, better to do it with a partner. And so we are both pursuing the DoD Air Force approach and the partnering thing.
And then what is next for AtomBeam following your current capital raise? We can't, go into details, but in a broad sense,
Broad sense, it depends how fast we raise the money, how fast we raise a big chunk of money, put it that way. And part of what I'm trying to do with a combination of the thing with Inmarsat and with Lockheed, and there's others out there, is build a relationship up. Lockheed already says they want to invest, right? And so you get them, you get somebody else. Then once we get this capital, you're looking at it. What we want to do is this. We want to build out the FPGA. We want to make the searchability thing a big deal. You're looking at it. That's the plan. And, and then this is, security piece. Look, what everybody is slowly waking up to is the fact that almost every freaking IoT device that isn't like either a bank or the DoD or whatever, almost all that stuff has no security at all. And everybody's especially worried about cars. Why? It's like, oh, I'm taking over your car and I'm going to steer it for you. How about that? And, oh, look out for that wall. Oh, sorry. There's going to be that. It's going to start to happen. And then people are going to freak out. And then you're going to see everybody focused on IoT security all of a sudden, even though everybody says, oh, it's a big deal. They aren't doing anything. And part of the reason they don't is because it's expensive. And it takes extra bandwidth, it takes extra compute, and ours isn't any of that stuff. Ours fixes everything with a light, tiny little app that just, fixes everything in a shot. And it's even reducing the size of the data. So the compaction piece becomes the secondary thing. So mentioning that, but getting back to it, these are the key things, what you're looking at. These are the initiatives. Make it easy to use, get in the hands of as many people as possible, keep focus on the things that we're doing now so that we don't run off after shiny objects. We are really trying to stick to the knitting, and that is what's going to make this thing really rock.
We do have one more question. We are coming down to time, so let's.
Oh, yeah.
You mentioned in your start engine pitch that you don't have any competitors. Why isn't anyone else in your field, and how large of a head start do you have on potential competition?
Yeah, well, they're called patents. The thing is that compression has been around since the 70s. And there's lots of been research and thinking and smart people working on it and stuff. But at the end of the day, nobody else has anything that does what our stuff does. It just, it isn't, I should restate there isn't competition. The competition is, let's take the Saab example. They would have to go out and build new radios or buy new radios to put into their fighter aircraft. Okay, that's the competition. The competition for Inmarsat is launch higher capacity satellites. So launch a new constellation of satellites at like $1 billion or whatever, or multiple billions, to upgrade the amount of bandwidth they have. That's competition for us. This is a lot cheaper than any of that stuff. So, am I answering the question? I'm trying to remember if I got it all.
Yeah, so I'll just reread the question. Is you've mentioned in your start engine pitch that you don't have any competitors. Why isn't anyone else in your field? And how large of a head start do you have on potential competition?
So the reason why nobody else is doing this is because no one else has thought of anything that does this. And thanks to our technical founder, Ashgard, that's why we have this and nobody else doesn't. We have a big head start because there isn't anything else that's emerged. And so I don't know, I can't tell you that there's how long it would take for somebody to catch up if somebody came up with something else, but they haven't. And so I don't know. I mean, I would say we've done a lot of development. We've got a lot of patents. We've got a lot of traction and people using it in the DoD and Lockheed Alliance and all that stuff. There's just no, it would be very hard for somebody. I'm not saying impossible if they could come up with something, but people have been trying for 40 years to come up with something and they haven't. So there.
That is our time. Unfortunately, is there another page you wanted to go over, or is that the last?
No, I think the last one was just a, fancy page that doesn't really tell you anything. So.
Before we wrap, Charles, is there anything you want to leave, the viewers here with before we hop off?
Well, I just want to thank everybody for, coming in and investing. And I really think we have something cool. I'm personally deeply invested in this thing, both monetarily and in terms of my time. And I think it's all about execution, and execution is all about making it easy.
Yeah. And for those, who wants to rewatch the webinar, don't worry, it's been recording this whole time. So we will have a recap around, this webinar on the Start Engine page. So please check out that Start Engine page, click that heart button on the top right-hand corner and stay up to date with AtomBeam. Like Charles mentioned, they did extend the campaign, but, we're not going to be extending it forever. So get in now. It's, before this opportunity, slips up. With that being said, thank you everyone for tuning in today. Thank you, Charles. Thank you, audience.
Right. And, you can reach out to me and ask questions if you like. So feel free. All right. Take care. Thank you very much for everybody for coming.
Bye-bye.